Yo, I cannot even tell you how excited I am about this next part of this lesson. If you're in advanced calculus of any sort, A, B, B, C, you are going to need to know how to do this. This is all about starting out with a random graph of f of x and then being able to rough sketch a graph of f prime of x. I'm going to show you my secrets of how to do this. I love doing this. So join me, won't you? Of course you will. Let's rock. So we've got here a graph of a line. Our goal is to sketch the graph of f prime of x, the derivative of f, given that graph of f of x. Now here's the important part, and I wrote this down here in quotes. The slopes on f of x, or of f of x, are the y values on f prime of x. Remember that f prime of x gives you the slopes of f of x anywhere. So if I want to graph f prime of x, I'm being asked to graph the slopes of f of x as y values on here. So what do? Well, I look at this and I describe it a bit, and I notice that we are positive everywhere and we're constant. Our slope is never changing. So let's just kind of describe the slope. So the slope is greater than 0 and constant. So then the y values for f prime of x would need to be positive and constant. What do we know that is positive and constant? Well, that would be a straight line. Now, it's got to be above the x-axis because it's got to be positive. And here's the thing. Clearly, I can't draw a straight line, number one. Number two, so imagine that's perfectly horizontal. Number two, when we're doing this out on this picture, we don't know how high or low this y value should be, but it cannot be on the x-axis because our slope's not 0, and it cannot be below the x-axis because our slope is positive. So the y values, or the slopes of f prime's y values, must be positive and constant. That's it. So then how do we deal with a graph like this? Well, we've got changing slopes. So here we've got to kind of narrate what's going on. Let's go on the journey here. I like to put a plus sign here to describe what the curve is doing in terms of slopes. Our slopes are positive, but they're getting less positive, right? If you put like little markings here, 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 and then there, you'll see that the slope goes positive but less positive until it hits 0 right there. So the slope right here is 0. So I'm going to mark that. Anywhere there's a slope of 0, that's not bad. And we're going to start out with positive y values. Then as we go past this maximum value here of this parabola, we see that we have slopes that get more and more negative. So we've got some curve whose y values must start out positive, go to 0, and then go negative, and never bounce out of that. Well, that would be a line. The steepness of the line, I don't know, but that line, I will explain why it matches perfectly with this. So we'll sketch this thing out. So if you take a look at this, the slopes here are pretty positive. So the y values of f prime needs to be positive, and I guess I should mark this as f prime, and that is f prime right there. So if you look at this, the slopes are getting less and less positive. You might be like, what? Here the slope is positive, but less so than here, and here it's even less positive. Here the y value is pretty positive, less positive, less positive, less positive, until we approach the slope of 0. Sweet. Then, as we exit the positive slopes, on the right side you got increasingly negative slopes. Well, we've got more and more negative y values that get more and more negative. But again, it never bounces back, and we start out with positive y values, go to 0, and then negative y values. And some students are confused and they say, wait a second, dude, this curve looks nothing like that curve. I get that. But again, the y values on the line must match with the slopes at the same corresponding x values on this curve. So the slope here is 0, the y value on the derivative is 0. The slope here is pretty positive. So is the y value in f prime. The slope here is negative and getting more negative. So too does it happen that the y values are negative and get more negative. Nice. And of course we'll have exercises on this at the end of this. So, the end of the whole lesson, and it's worth practicing. Let's go to two more abstract ones here, shall we? And we'll really put our idea to the test. So, again, sketch the graph of f prime of x given each graph of f of x. I also want to just kind of give a word to the wise. Be patient with this. This is not something where you'll watch and be like, dude, bro, I totally got this. I'm going to rock it. I'm going to teach this harder than Groden's going to teach it. And maybe someday you will. I hope you do. But for right now, it might be a little confusing, and that's okay. This is one of those concepts you'll grow into. You need to practice. Maybe watch the video over a few times to understand it. Again, the slopes of f of x are the y values on f prime of x. Because f prime of x, those are the slopes of f of x. So I look at this, that's a slope of roughly 0, which means from here until here, our graph of f of x should have a y value of 0. Now I'm going to put an open circle there because there technically, and I guess technically here too, I should have an open circle. So let me erase that, shall I? Take my cool little eraser. The reason why we should have open circles here is at these endpoints, we don't have a derivative. I don't know what the slope is at the endpoint, and here the slope from the left is different as it is from the right. Now notice here we've got a nice constant slope. It is positive the whole time and constant. So I've got a y value, again an open circle here, don't know what the derivative is there, and an open circle here, we're not differentiable, we got that corner, but I've got a y value that's positive and constant because a line has the same slope the entire time. Then look here, so I'll put a plus here, a 0 here. We've got a negative slope, it's constant, so that means that the y value of f prime will be negative at a same exact rate because it's a line and the slope doesn't change. So I don't know, I'll put it down here. I don't know what the height of this negativity and this positive value should be. Just know it should be negative. And I'll put an open circle here where again, it's not differentiable. We got that corner. Boom, and that should be a horizontal line right there. Again, negative y value that is constant. And then here we've got a 0 slope. So it's an open circle all the way until we get right here. Oh yeah, so it stays at a y value of 0 because again, f prime stays at 0. Then, as we go from this x value to that one, that's really negative. That's steeper than this is, so we better have a y value that is below this one and more negative. But again, it's a line, so it stays the same. And really, it should only go until there where it ends, it lines up. Your x values have to line up in both the f graph and the f prime graph. What I mean by that is, here you've got a slope of 0, so on this entire interval you got a y value of 0, but the second we switch over and it's not differentiable, it's got to be reflected at that same x value. You ready for the last one? Me too. Let's go. So here we've got maybe a quartic, who knows, maybe it's a graph that bounces back later, but all we got is this right here. So again, I'm going to employ the idea that the slopes of this are the y values on f prime of x. A little f prime of x John there. John, by the way, for those of you not from around the Philadelphia area, means we'll put a little thing right there, right? How about that John? How about that thing? So if it's made it to your neck of the woods, pretty cool little saying, J-A-W-N. It's a Philly thing. Anyway, so looking at this, now that you've had that slang lesson, let's do some more calculus, shall we? So I've got a positive slope here, but notice that the slope gets less positive, right? Until finally we hit a horizontal tangent and a slope of 0. So lined up with that, I've got a y value of 0 on my derivative graph because the slopes on f of x are the y values on f prime. I'm not going to say that anymore, probably. I keep going here. I've got a negative slope that gets more negative and then less negative. So they're pretty steep, getting steeper and steeper until we get to about here, and then the slopes get a little bit less steep until we get to another horizontal tangent line, so another y value of 0. I think the y value of 0s are nice things to put down first in terms of organizing your steps. Then we get more and more positive, and then slightly less positive until we hit another horizontal tangent line, another y value of 0. And then we increase getting more and more negative. Okay, what curve goes from a positive y value through 0 to a negative y value, back to a positive y value, and then back to a negative one? Well, let's think about this. Well, we got to start positive. How positive? I don't know. So I'm going to start up here, and I think I just want to just sketch this. It doesn't have to be perfect. That arm right there represents this part. You've got positive y values because your slopes are positive the entire time, but getting less positive. The slopes are getting less and less steeply positive until we hover out at 0. Then we're going to get more negative until right about here, where we're going to be most negative, right there. So that kind of bounces down. And then we're still going to be negative, but start to bounce back up until we hit our 0 slope, which makes sense because our slopes are more negative, less negative, less negative, less negative, 0. More negative, more negative, more negative, less negative, 0. Oh, it's beautiful. We'll keep going. Now our slopes will get increasingly positive till about, I don't know, roughly there. So more and more positive. And then it's going to come back down to earth. Our slopes are still positive, but getting less positive as we go on. Less positive, less positive, less positive. 0 horizontal tangent line. And then we're going to get increasingly negative. Oh, it looks like a cubic function. Sweet, there's a pattern there. The point is, if we can break these things down into pieces and understand the idea that the slopes of f of x are the y values on f prime of x, you are going to be a boss at these very challenging problems in the not too distant future. Get good at these, practice them early and often. It's one of those things that you'll be uncomfortable with for a little bit, so be patient. I'll see you next time.